How does AI recognize cats, faces, or even traffic signs? The secret lies in something called convolutional neural networks, or CNNs. Today, we'll break down CNNs step by step, see their architecture, and even build a tiny CNN in Python. A CNN is a special type of neural network designed for image data. Unlike traditional networks that just look at raw pixels, CNNs use filters, also called kernels, to detect patterns, like edges, shapes, and textures. Layer by layer, CNNs build up from simple features to complex objects, like recognizing a cat, a car, or a face. Let's break down the CNN architecture into three main parts. Convolution layer applies filters to detect features. Pooling layer reduces the image size while keeping important info. Fully connected layer combines features and makes the final classification. Think of it like this. The first layer finds edges, the next layer finds shapes, and the final layer says, this is a cat, or this is a dog. First, we import Keras and the key layers we'll need: convolution, pooling, flatten, and dense. Next, we start our sequential model. We add convolutional layers to detect features, and pooling layers to reduce the size while keeping important information. Then, we flatten the feature maps into a single vector, and pass it through dense layers to learn deeper patterns. The last dense layer uses sigmoid activation for binary classification, cat or dog. Now we compile the model with Atom Optimizer and binary cross-entropy loss, tracking accuracy as our metric. Finally, we print the model summary, showing each layer, its parameters, and how the CNN is built. And that's it. With just a few lines of code, we've created a CNN that can classify images. So why are convolutional neural networks, or CNNs, considered so powerful? The secret lies in three things: efficiency, feature extraction, and their real-world impact. First, CNNs reduce computation. Instead of looking at every single pixel individually, CNNs use small filters that scan across the image. This means the network focuses only on the most important regions, making image recognition much faster and more efficient. Second, CNNs automatically extract meaningful features. Unlike traditional methods where humans had to decide what features to look for, CNNs learn them on their own: edges, shapes, patterns, and even complex objects. This ability to see without manual programming is what makes them so intelligent. And third, CNNs dominate real-world image tasks. They power face recognition systems in smartphones, guide self-driving cars by reading traffic signs and detecting obstacles, and even help doctors analyze medical images like X-rays and MRIs for faster, more accurate diagnoses. Tomorrow, in Day 23, we'll explore RNNs, recurrent neural networks, perfect for handling sequences like text, speech, and even music. Stay tuned.